Let's take some time and talk about hinges before we continue to talk about compound systems. So what is a hinge really? Of course, we are all familiar with that when it comes to our door in our home. But the way engineers draw them, if they connect, for example, two rigid bodies, it would look something like this. So we have a circle here that symbolizes a hinge. This is the hinge. And what does the hinge do? Just as it does in your door at home, it allows rotation. And this is where the definition lies, right? So allows rotation. And remember from our basics in this class when we talked about the warm-up that rotation is very closely related to a moment, right? So a moment, what was a moment? A moment is restricted rotation. And so if you have a hinge which allows the rotation, then you cannot have a moment anymore, right? So the moment has to go to zero at a hinge. And this is really what you need to understand. It's difficult to understand this just by definition, but this will become clear throughout the class, that at the hinge, so at the hinge, the moment has to be zero. And let's be very clear here. Sometimes in the literature you read that the sum of the moments is equal to zero at the hinge. And I don't know which color to use or like how to make this more important, but this is not, right? This is not the sum of the moments is equal to zero. So this is true, but it is very different than saying that the moment at the hinge is equal to zero. Let me clarify the difference. So the sum of the moments for static systems is always zero at every location. It's zero here, it's zero here, it's zero here, here, anywhere. But the moment to be zero is only true at the hinge. So the correct way to write this, so instead, the moment at the hinge is zero. And therefore, we would say that mh is equal to zero. It is a very important differentiation to leave this sum of the moments out. It's that the moment at the hinge is going to zero. You will understand this more when we talk about internal forces, because technically the force at the hinge or the moment in the hinge is technically an internal moment. And of course we haven't talked about this, but for now please understand that the hinge allows rotation, and because it allows rotation, let's say this can move in this direction, and this direction, and this can move in this direction, and this direction. That is why we have another boundary condition, and the boundary condition is the moment is equal to zero. This is an initial condition we always had. This does not help us at all, the sum of the moments being equal to zero. We only get help through the hinge if we understand that the moment at the hinge is equal to zero. And that now allows us to move forward to compound systems, because now I can use hinges to actually connect systems.